Hello everyone, I am Janvi Behel, a student of Dharam Singh Desai University. Me and my colleague Ms. Priya Gagnani, currently in the final semester of our undergraduate course, have been working on a computer vision based project at EduTech Learning Solutions, Baroda. So what is computer vision? Computer vision is a science that is quickly gaining momentum. It is concerned with the automatic extraction, analysis, and understanding of useful information. It involves the development of a theoretical and algorithmic basis to achieve automatic visual understanding. Used in augmented reality and biometrics, it is increasingly being adopted in a variety of applications. All the image processing algorithms that we carried out during our internship were performed on both the graphical processing unit and the central processing unit. Though all of us are mostly not oblivious to the basics of a CPU, let me still quickly brief you about it. A CPU is often called the brain at the heart of the computer. It is an indispensable part required to run a majority of engineering and office software. However, some tasks can bog down the computer's central processor. In such case, a GPU is required to fasten the processing. A GPU is a specialized type of microprocessor primarily designed for quick image rendering. They are powerful enough to perform rapid calculations and suitable enough to address 3D visualization in image processing, big data, and deep machine learning problems because of their parallel programming architecture and multiple cores that can perform multiple functions at the same time. We used the NVIDIA Jetson TX2 board as our GPU. In NVIDIA's own words, Pascal, the architecture which the board is built on, is the most powerful architecture they have built. NVIDIA Jetson TX2 is an embedded system-on-module with dual-core NVIDIA Denver 2 plus quad-core ARM Cortex A57 8 GB 128-bit LPDDR4 and integrated 256-core Pascal GPU. Along with 8 GB LPDDR4 memory, a 32 GB eMMC flash memory is integrated on the module. The CPU complex consists of two ARM V8 64-bit clusters which are connected by a high-performance coherent interconnect fabric. The module also supports hardware video encoders and decoders which support 4K ultra-high definition video at 60 frames per second in several different formats. Being an ideal choice for intelligent edge devices like robots, drones, smart cameras, and portable medical devices, it is deployed in computer vision and neural net processing. Self-driven cars as well as Alexa-like robots extensively use the TX2 board. We used Qt for building and running our image processing programs. Qt is a free and open source widget toolkit for creating GUIs and cross-platform applications that run on various hardware and software platforms such as Linux, Windows, Mac OS, Android, or embedded systems with little or no change in the underlying code base. The version of Qt that we used is 5.12. Qt is extensively used in Google Earth, Adobe Photoshop, Bitcoin Core, TeamViewer, and VLC Media Player, to name a few. We use the rich open source computer vision and machine learning software library of OpenCV. OpenCV was built to provide a common infrastructure for computer vision applications and to accelerate machine perception in the commercial products. The library has more than 2,500 optimized algorithms. These algorithms can be used to detect and recognize faces, identify objects, trace camera movements, and track moving objects. OpenCV algorithms find its use in various disciplines owing to its extensive set of algorithms. This is the documentation and functionality of various algorithms of OpenCV version 3.4.0. We have used some of these modules in our tasks. To name a few, we have Core, which is the core functionality, IMG Proc, which is used for basic image processing operations. The module High GUI has features such as resize window, create trackbar, and named window for GUI applications. Features 2D was also used by us in our algorithms. It has libraries for feature detection and descriptor matching. These are the CPU modules. There are also CUDA modules which are mentioned here. CUDA stands for Compute Unified Device Architecture. It is a parallel computing platform and application programming interface model created by NVIDIA. CUDA stands for Compute Unified Device Architecture. CUDA is a parallel computing platform and application programming interface model created by NVIDIA. The CUDA platform is a software layer that gives direct access to the GPU's virtual instruction set and parallel computational elements for the execution of compute kernels. The CUDA platform is designed to work with programming languages such as C, C++, and Fortran. CUDA also supports programming frameworks such as OpenACC and OpenCL. These are the CUDA modules. CUDA filters is for image filtering. CUDA legacy gives us legacy support. CUDA object detect has object detection algorithms implemented. Now we'll quickly go through the image processing algorithms that we implemented by building and running them on Qt. Here we implemented an algorithm to find the grayscale version of the original image. Here we applied an algorithm to resize the original image into half of its original size. This is the output of the Sobel operator applied to a video file. These are the edges detected from the original image by applying the canny edge operator. This algorithm finds out the descriptors of a video file. This is the descriptor matching process. It is useful in object detection. This is the background-foreground segmentation. It iteratively updates the model to find the foreground mask and the background subtractor. This is the original video image. This is the mean background image that is found. This is the foreground image and the foreground mask. This is the Laplacian video applied on a video. The value of sigma can be increased. Increasing the value of sigma will reduce the noise and also the sharpening effect, whereas reducing the value of sigma will decrease it and will have the inverse effect. This is the output of the hue transform applied on the image. As shown, it detects the lines. This is the grab cut algorithm. A rectangle is drawn around the object we want to segment. The pixels around the rectangle are hard labeled as background pixels. The pixels lying inside are iteratively labeled as background or foreground depending on its relation with the other hard labeled pixels. This is the output after one iteration, after two, and after three. As seen, we can segment the foreground. We profile all our codes using the NVIDIA Nsight Eclipse Edition. To see our code performance, we shall acquaint ourselves with the parameters we observed and the technical jargon related to profiling. So what is profiling? Profiling is the dynamic program analysis that measures, for example, the space or time complexity of the program, the usage of a particular instruction, or the frequency and duration of function calls. The information obtained from profiling serves to aid program optimization. So why should we profile our GPU codes? We know that GPU supports parallel programming, so it has many units working in parallel and hence it is common to be bound by different units for different parts of frame. So it makes sense to find out which functions occupy a larger amount of time and also to look at the memory occupancy issues. We use the NVIDIA Nsight Eclipse Edition, which is a full-featured IDE powered by the Eclipse platform that provides an all-in-one integrated environment to edit, build, debug, and profile our code. What makes the Nsight Profiler special is that it is graphical, making it easier to read. It highlights potential performance problems at specific source lines within application kernels. As visible, the program that we want to profile is already open here. We've done the necessary settings. We've included the library paths in our includes folder. Upon building the program, we get a executable in the debug folder. So let us straight away profile the program. So this is what we've got after profiling a code. This is the profiling overhead. This is the time it takes to compute for all these functions.
These are the parameters that we observed for the API calls. This is the start, the end, and the duration of the API call. We also observe the grid size and the block size. The grid size, that is maximum grid size बोलूं? ये बहुत बड़ा number है. क्या number है ये? These are the parameters that we observed. We observed the start and the end time of the API call, the duration, the grid size, and the block size. These are the registers per thread and the shared memory per block. So let us go over what the thread, the shared memory, and the registers mean. A thread is the instance of a kernel, whereas a kernel is a function called by the CPU and executed by the GPU. So a thread is a portion of code that handles part of the data. Threads come together to form blocks that cooperate by sharing data through shared memory and synchronize their executions to harmonize memory access, making them faster. Blocks then gather into grids. The advantage of grids carrying threads executing various functionalities is, as I mentioned, faster processing. Another advantage of these grids is that it contains a number of blocks that are all processed simultaneously to get the optimum limit, closely linking it to the hardware. The maximum number of threads per block is 1024, whereas the maximum number of threads per warp size is 32. As visible here, the number of registers per thread we get is 40. It is good to have a higher value for this parameter as it ensures there are more registers per thread, ensuring faster memory access. There are some types of there are many types of memory. One is the global memory, the shared memory, and the register memory. The global memory is embedded in the graphics card. The shared memory is a small memory area. It allows to lessen the limitation imposed by parallel processing of threads by allowing them to communicate and thus interact between them quickly without going through the memory of the graphics card. The register memory is the fastest to access in the global and local memory. We can also observe these parameters. It is low kernel concurrency. The concurrency of this program is low as there are not many complex functions. The throughput, the compute utilization. In the performance critical kernels, after we do the perform kernel analysis, we find out the rank, that is the importance of the functions, and the description of the functions, the kernels that they use to execute. So this is all about profiling. Now we'll go over to the next part which will be explained by my colleague